Okay, today we're going to talk a little bit about converting from radians to degrees. Um, there are two different types of angle measurements that we're going to talk about. One, radians, and one you're probably a little more familiar with, degrees. Okay. As you can see, there's some basics that we need to understand to convert, and you probably recognize the fact that in a circle there is 360 degrees, and there are 2 pi radians. So those two are equivalent. And similarly, there are 180 is the same as pi. Pi over 2 is the same as 90. Pi over 4, 45. Pi over 360. You can see all these relationships, and if you think about it a little bit, then those are pretty easy to see. Now, but sometimes we don't want to have to memorize all of these correlations, but if we start adding them together, for example, 2 pi over 3 is 120, which is, 90 plus 30, or 180 minus 60. Well, if that's not very helpful, then we can use these conversion factors, where since pi equals 180 degrees, we can set up a conversion that is pi over 180 is equivalent to 180 over pi, because those are both forms of 1. And which one we use just depends on whether we're trying to convert from radians to degrees or degrees to radians. So let's look at some examples. For example, if you wanted to convert 135 degrees to radians, then 135 degrees, then you're going to use pi over 180 so that the degrees will cancel out 135 and 180. And the way that I think about this is reducing fractions. So 45 is a factor of both of these, okay? And so that will reduce, and I will get 3 pi over 4. And you can see here is the angle, 3 pi over 4, displayed in standard position, which is where one side of the angle is centered at 0, and then we move the other side of the angle over there. And so those two are equivalent, 3 pi over 4 and 135 degrees. Now, if I'm converting from radians to degrees, then I'm going to want the pi in the denominator. So for example, if I convert 3 pi over 2 radians to degrees, then I'm going to multiply it by 180 over pi, so that the pi's will cancel, and that's kind of my guideline. And then I also notice that I've got a factor of 2 that I can reduce as well, and then 3 times 90 is 270 degrees. And here is that 3 pi over 2, aka 270 degrees, written in standard position. You can see those two are equivalent. Now, let's do some examples of not nice numbers. So most of the time you're going to be dealing with nice numbers and converting, and you're going to have those reference angles where you can kind of think, okay, 180 plus 30 is 210, and then you get 7 pi over 6 is equivalent to 210. But sometimes in your homework you're going to have not nice numbers, and you're going to use a calculator, and you're going to use an approximation of 3.14. But you're still going to use that guideline of whether pi is on the top and degrees is on the bottom by the units. So 112 degrees is on the top, and so 180 degrees is going to go in the bottom on the calculation. And you'll find that when you multiply it by, well, I'll go ahead and show you what that looks like. So if I take 112 and I multiply it by 3.14, and then I divide that number by 180, then I'm going to get 1.95 radians. We're always going to round to 2 decimal places. Okay, so 1.95 radians, which is somewhere around there. Now, if I want to convert 1.5 radians to degrees, so even though there's no pi sign, I know that it's radians, so pi is going to go in the denominator. Okay, and I can go back to the my calculator, and I can say 1.5 times 180 divided by 3.14. Oops. Let's see if that works. And I get 185 or 85.99 degrees. And there's that angle in standard position. All right, you can go on and do homework 5, which has these type of problems in it. And you can, if you have any questions, I'll be available online, either during class period or during student meeting block.